Got a new project idea, maybe a smart gadget or a custom robot? Most makers reach for a Raspberry Pi, tiny, powerful, versatile. But is it always the best choice? For many projects, a Pi is overkill. Enter microcontrollers, smaller, cheaper, and often a smarter fit. Today we'll break down 5 reasons why a microcontroller like an ESP32 or Arduino might be the better pick for your next build. Let's dive in. Let's dive into a critical aspect of choosing between a Raspberry Pi and a microcontroller: power consumption. It's a game changer, especially when you're thinking about battery life or remote deployments. Raspberry Pis, being essentially mini computers, run full operating systems. They're powerful, versatile, and draw a lot of power even when idle. This is because the OS and background processes are constantly running, consuming energy. Microcontrollers, on the other hand, are built for efficiency from the ground up. They focus on doing specific tasks, using only what they need, minimizing energy waste. And they can enter deep sleep modes, shutting down almost completely when not actively processing. In these sleep states, they sip power in the microwatt range, an incredibly small amount. That means battery-powered projects, the kind that need to last for extended periods, like a garden sensor that runs for a year, collecting data and sending updates, are easily possible with microcontrollers, thanks to their ultra-low power consumption. But achieving the same with a Pi would be significantly more challenging, requiring a much larger power source. If your project needs to be portable, fitting in your pocket or attaching to a moving object, remote, deployed in a location without easy access to power, or energy efficient, minimizing your environmental impact and extending battery life, a microcontroller isn't just better, it's the right tool for the job. It's essential. It's the foundation for reliable, long-lasting operation. It's the difference between a device that needs a power bank, constantly tethered to a charging source, and one that can run for months, even years, on a single coin cell. For always-on, low-power projects where continuous operation is paramount, microcontrollers open up a world of possibilities, enabling applications that would be impractical or impossible with a Raspberry Pi. Efficiency is their superpower, allowing them to excel in situations where power is limited and longevity is key. Let's talk cost, a crucial factor in any project. We need to consider not just the initial price tag, but also the long-term expenses and hidden costs that can quickly add up. A Raspberry Pi might seem cheap at first glance, offering a lot of computing power for the money. But remember, you'll need extras: an SD card for storage, a reliable power supply to keep it running, and perhaps even a case to protect it. These accessories can significantly increase the overall cost. On the other hand, microcontrollers like the ESP32 or the Pi Pico offer a more streamlined approach. They often cost just a few dollars, making them incredibly budget-friendly. And the best part? They often require no extra parts to get started, simplifying your project and reducing expenses. Simplicity matters, especially when you're dealing with complex projects or tight deadlines. This is especially true if you're planning on building more than one unit. The more complex the setup, the more time and effort it will take to replicate. Flashing firmware to 100 microcontrollers is a relatively quick and painless process, but setting up 100 Raspberry Pis with their operating systems and configurations can quickly become a major headache. The hardware is inherently simpler with microcontrollers, leading to a shorter and more manageable bill of materials. As a result, deployment is often a breeze, allowing you to get your project up and running quickly. When it comes to scaling up your project for mass production, microcontrollers offer significant advantages, saving you valuable time, money, and potential frustration. They're specifically built for efficient and streamlined processes, making them ideal for cost-effective projects of any size. So, when you're ready to transition from a simple prototype to full-scale production, microcontrollers are often the clear winner, providing a reliable and scalable solution. Here's where microcontrollers really shine: real-time performance. They respond instantly and predictably. No operating system delays, no multitasking hiccups. For projects like drones, precise motor control, or high-speed data, you need actions to happen at exact moments. Microcontrollers handle interrupts in microseconds, making them perfect for robotics, signal processing, and anything needing strict timing. It's not about raw speed, it's about being reliably on time. For real-time control, microcontrollers are unbeatable. Reliability matters. Raspberry Pis rely on SD cards, which can fail or corrupt with power loss. Microcontrollers store code in robust internal flash memory. No file system to corrupt, no SD card to wear out. Power cycle them 1,000,000 times. They'll just keep running. This makes microcontrollers ideal for rugged environments from cars to factory floors. Fewer failure points mean more dependable projects. When you need something to just work, microcontrollers deliver. Simplicity equals reliability. Microcontrollers are made for talking to the real world, reading sensors, toggling pins, controlling motors. Their hardware is built for direct, fast, and efficient I/O. With a Pi, every action goes through layers of software, adding delay and complexity. For simple tasks like blinking LEDs or reading buttons, microcontrollers are faster, leaner, and more reliable. Don't use a sledgehammer for a thumbtack. Pick the right tool. For dedicated I/O, microcontrollers are the clear choice. So, the big question, is the Raspberry Pi ever the right choice for your project? It's a powerful piece of kit, but it's not always the perfect fit. Let's delve into when it truly shines. Absolutely. If you need a full desktop environment, with a graphical user interface and all the bells and whistles, multimedia processing capabilities, or advanced networking functionalities, the Raspberry Pi is often unbeatable in terms of price and performance. But when you're dealing with battery-powered applications, cost-sensitive designs, real-time control systems, or simple input-output projects that don't require a full operating system, microcontrollers are often the smarter, more elegant, and power-efficient solution. They're designed for these tasks. Ultimately, it's all about carefully matching the right tool to the specific task at hand. Both platforms are truly amazing in their own right. They each bring unique strengths to the table. And knowing precisely when to leverage the power of each one is what truly sets you apart as a better, more resourceful maker. Let me know about your own experiences and preferences in the comments section below. And if you found this video helpful and informative, please don't forget to hit that like button and subscribe to the channel for more content. Thanks so much for watching, and happy making.